What's up, math scholars? It's a sunny Thursday out there, so that makes me happy. I'm actually going pumpkin boating this weekend, so I have some happy news to share. It's in Pittsburgh, so if you want to drive to Pittsburgh, yes. So hey, who's excited to use synthetic division versus that long division? So much easier. Woo! Synthetic division can be so fun. You are not showing much enthusiasm at 7:59 a.m. class. Alright, so synthetic division can be used if you're dividing a polynomial by a cute little binomial. So if your divisor is only two terms, such as, I don't know, x minus 3 or something like that, then you can use synthetic. Now, if your divisor is larger, like let's say my divisor is x squared plus 6x minus 1, then you have to use that long division. There's just no other choice. But if you have a cute little binomial as your divisor, good news. Synthetic will work. Okay? Okay. I like it. Okay, so first up, I've got my original polynomial. I've got my divisor. Look, it's a cute little binomial. And since it's a cute little binomial, we can use synthetic division. Here's how we would set it up. It's the same bracket we did last week on our quiz with the little backwards L for the square and the plus sign. So you do have to remember synthetic division. You add down. Long division is when you subtract down. You're going to set up the numbers in here just like you did last week. So it would be a 2, and then a 1, and then a -8, and a 5. I did not need any zeros in my setup because I had all terms accounted for. Cubic, quadratic, linear, and constant. They're probably wondering what's going to go in this box. You can't put an x plus 3 in the box, which is what my divisor is. You have to put the solution to the cute little binomial in the box. -3, very good. So the solution to the binomial is a -3, and that's what goes in the box. A solution is a value that would make the binomial equal to 0 when that number is put in for x. We did that in chapter 1.
Yeah.
Okay. So if you never learned synthetic, now is the time. Some people I feel like never quite learned synthetic last week. They just missed that problem on their quiz. So to do synthetic, this 2 has to go down to here. If you forget to drop your 2, you'll just be off from there on out. You do 2 times -3, get -6. Add straight down. -5 times -3, careful. Beware of the double negative. That's going to be a 15. Add straight down. Get 7. 7 times -3 is -21. Add straight down. Get -16. That's a little bit different. I'm still going to do my double bar line like last week. Last week we would just say -16 is our answer and we'd walk away. Well, today I'm going to explain what we're seeing. This 2, this -5, and the 7 are actually representing your quotient. Our quotient is 2x squared minus 5x plus 7. You kind of work backwards. This is your constant term, your linear term, and your quadratic term. And then your remainder is the guy that you circled, -16. Isn't that wild? I know. So last week when you're like, why are we doing synthetic when we could just do direct substitution? We were doing it to lead to bigger things, and this is the bigger thing we were leading to. Dividing polynomials and factoring polynomials. We're doing this to factor in a few minutes. How fun was that? You ready to try another one?
Yeah.
Do you want to try it like all by yourself, like with the board buddy?
By myself.
I think you're ready for that. Alright, so I'm going to kind of pause the video and I'm going to have some board buddies come up and try this. We're not quite ready to graduate. Hey people in the video, we're back. The main thing I heard discussions on with my buddies is who's going to go in the box. It's a -3 that needs to go in your box because the -3 is the solution to our cute little binomial right here. And then you can see my setup, you can see my remainder ends up being 11. And then the 1, 1, and -4, we made it into a polynomial. 1x squared, 1x, and -4. Okay? Any questions at your seats? Everybody that was not at the board, you did okay? Okay, maybe do one more board buddy. Do another board buddy. All right, hey board buddies, we end up putting a 1 in our box for our setup and getting 4x squared, 5x plus 2, and 9 as a remainder. So how'd it go if you were not at the board? Pretty good. I'm seeing a couple thumbs up. All right, well, let's move on to how we're going to actually factor using this process. So this is something to write down, what you're seeing in my little red cloud. Your original polynomial would have a factor x minus 3 if and only if f of 3 equals 0. So basically, if your remainder ends up being a 0 when it's all said and done, your original divisor was a factor. So we haven't seen any today that got a remainder of 0, but we're about to start seeing that happen.
And that's good.
And then we'll be able to take that quotient, factor it further, and we'll have the whole polynomial factored. It's actually pretty cool how the process works. Okay, so here's our next one. They're basically telling us, they're flat out telling us that x plus 2 is one of the factors. And we're trying to factor this down completely. So what you're going to do is you're going to start off your process. You're going to put the solution to that binomial in your little box. You're going to set up your synthetic division. 3 is my x to the third term. Negative 4 is my x squared term. Negative 28 is my x term, and negative 16 is my constant term. So I wasn't missing any. That's good. I didn't need any zeros. We're going to start by dropping the 3. 3 times negative 2 is negative 6. Add down. Negative 10. Negative 10 times negative 2, beware, that's a double negative, is 20. Add straight down. Negative 8 times negative 2 is 16. Add straight down. Awesome. So when you get that 0 there, it means that what you divided by was a factor. So x plus 2 is one of our factors. You could just write that down at the bottom. X plus 2 is one of the factors. Now, what we're left with, this quotient, is a polynomial, 3x squared minus 10x minus 8. So basically, so far, this is what factor form would look like. Maybe we're done right now. Maybe we're not done right now. Maybe my 3x squared minus 10x minus 8 can factor even further. We'll need to at least explore that. What method would we use to try to factor it further? You guys should know after 2 days ago we did factoring all day long. You just don't want to tell me?
We don't want to do it.
Oh, you just don't want to do it. What method? Yes, it's the box method. Very good. So the students know that it's the box method. They're just less enthusiastic about using the box method. It doesn't take long. 3x squared goes here. Negative 8 goes here. You multiply it together to get negative 24. Help me out with my selection. What numbers will multiply to negative 24 and add to negative 10? I'm thinking negative 12 and 2. Sound about right? So my top row would have a 3x in common, making this an x, and this a negative 4, and this, I believe, would be a 2. So my final factored form would look like this. On my one side, I've got a 3x plus 2. On my other side, I have an x minus 4. And then I use that factor that they kind of started off with, that x plus 2. And that is factor form. How would you check it if you would want to? I don't know if you'd want to.
Foil.
You'd foil this whole thing out, and I can only do 2 at a time. So you do these 2 first, and then the box with the final. Yep, very good. Yep.
Why can't you use the box with...
Okay, our prompt is to factor this polynomial completely, given that x minus 4 is a factor. It's almost like they're starting you in the right direction, or at least giving you one of what's probably going to be 3 factors. All right, so let's set ourselves up. Who's going to go in my little box? A 4. What would my setup look like across here? 1. You need a 1 for this guy, for sure. 1, negative 6, 5, and 12. We're going to drop our 1 down. 1 times 4 is 4. Add straight down. Negative 2 times 4 is negative 8. Add straight down. And negative 3 times 4 is negative 12. Add straight down. So if you don't get a 0 here, you probably messed up your synthetic division, because they flat out told us that x minus 4 was a factor. So we should be getting that remainder of 0. All right, right now my factored form would be x squared minus 2x minus 3 with that x minus 4 that they originally provided us with. Do you think we're done, or do you think this stuff can factor a little further? It can go further. What method? Old-fashioned factoring. So we're just brainstorming numbers that can multiply to -3 that would add up to -2. And of course, we still have the x minus 4. -3 and +1. How's that sound? Awesome. Right, sometimes they word the question a little differently, so I'm going to pull up one like that, just so you're aware. Not the next one. Yeah, this one. They just worded it differently. Instead of telling you what a factor is, they tell you what one of the solutions is. 1, 0, or solution, a 0 is the same thing, the solution. One solution of this polynomial is 3. What's another solution? What's another 0? So you'll flat out put that 3 right here. It just means that the factor that would correspond to that solution is x minus 3. And then we're going to do it just like we've been doing before. So a 1, a -2, a -23, and a 60. Let's drop our 1. 1 times 3 is 3, add straight down. 1 times 3 is 3, add straight down. -20 times 3 is -60. And I guess to finish, you're just going to write this as a polynomial, factor, and find the remaining 2 solutions, because there's going to be 3 solutions. X squared plus 1x minus 20, how would that factor down? Mm, 20 and 1 would add to 19. No, I think you have to go with 5 and 4. +5, -4. But keep in mind, we're doing solutions of each binomial. So basically, in factor form, we'd be dealing with this. The solution to this binomial was 3. That was the provided solution. What's the solution to this binomial? And what's the solution to this binomial? So as far as actually answering their questions, we probably would have gone with A. It's the only one that had a good solution. And to checking is really easy. You could just take a -5, put it in for x, here, here, and here, and all of that should be 0. Because that's what a 0 does. That's what a solution does. It makes the value of the polynomial 0. People on the video. Hi, people on the video. This is going to be your graduation problem. I'm going to have some board buddies up here to do it. We just had a chat in the class. It said find the other zeros given that f of -2 equals 0. My class told me put the -2 in the thing, but they were right. It was putting that -2 in the box, so go from there. My people on the video, the answer. Hey, people on the video, so let's do this real quick. We got our setup 1 to -9 and -18. So you drop your 1, then that makes that a -2. That ended up being a 0, which is a slightly tricky that we hadn't seen that before. And then 18 up here. So of course we're getting that remainder of 0. This is what kind of stumped my students. They're like, we don't know how to factor x squared minus 9. And I told them you absolutely do. It's the difference of perfect squares. So you can square root your x squared, get x and x. You can square root your 9, get a +3 and -3, making those final 2 solutions, a -3 and a +3, to go with that first solution they provided you with of -2. So you guys got what you're doing? Who graduated? Who got that? It was harder having that 0 in there, so sorry for this little bit of a challenge. Let me show you what the homework is so people in the video can write it down. Right here, 12 to 32 even. Thanks for joining us for our video.